I would like to invite Efi Kaufman from Israel Ministry of Energy to talk about ICS and OT devices and assets management using Splunk. Yes, welcome. Hi.
Okay. Boy, those slides are really hard, but okay, so first, really appreciate all of you here that stayed this late into the conference, and really those that will be able to actually shut this down will be getting some $10 Amazon gift cards after my session. I'm glad that you laughed because this was really just a joke. So first I would try to see your hands. How many people here are really using Splunk or have some hands-on experience with Splunk? So counting 1, 2, 3, okay, even more than 10, more than I really expected. How many are configuring or using SIEM systems, ArcSight, QRadar? Okay, and really last question, hopefully, how many have hands-on experience with the so-called SCADA, ICS/OT, industrial control systems? Really hands-on experience. So this hand, yeah, you raised your hand, okay. Okay, not many of you. I see one over there. Okay, so I'll also try to touch on this point. So, again, my name is Efi Kaufman. I'm leading the so-called Big Data and Analytics in the Ministry of Energy Cybersecurity Center. Like I said before, we're using Splunk, and this is really what I'm into. I think, okay. So, in the minutes that we have, basically, I will share with you my experience or our experience in the Ministry of Energy Cybersecurity Center. I think it will be really interesting to most of you. I will make some references to similar projects. I don't have any demos, any code running. I think we had some excellent presentation before, but I will show you some details that you can afterwards check for yourself and actually see some interesting stuff that is also being done in the industry, pretty similar to what we are doing. We'll do some quick intro into IT versus OT, because again, not many people here know what really OT or SCADA is all about. Obviously, the main part of what I want to share here, again, I'm not about teaching you any rocket science, just share my experience, and hopefully it will light up some bulbs. And last, I will share the high-level architecture of basically what we are doing. And again, the whole thing about this presentation is just to provide you with an insight into this exciting ongoing project that we are doing. Share my knowledge. If you have any questions, if you're too shy to approach me afterwards, you can search for me on LinkedIn. I'm quite active over there. Just search for my name, and we can continue and discuss. So before we begin, first, the usual who am I slide. So this is just a kind of, a short chit sheet about my professional background up until now. I think that I was very fortunate as a teenager back in the early 1980s to start typing on keyboards, actually start coding, and haven't stopped since then. So, now as a parent to one boy and two girls in their late teenage, early 20s, when you're talking about, okay, what they will do and trying to share with you the kind of stuff that they are about to do when they will grow up, I think I was really lucky to actually continue dealing with technologies and computer up until now for the last 40 years. So with that, let's move into the Ministry of Energy Cybersecurity Center. So the Cybersecurity Center is actually located here in Beersheba. For those of you that are not Israelis, Beersheba was declared by the Prime Minister of Israel as the cyber capital of Israel. So we're sitting basically on the same floor as the national CERT. They're focusing on IT, and we're really focusing on OT, on SCADA systems. And basically, we have two objectives in this cybersecurity center that we are running. So the first one is really to provide what we're calling a sector-wide comprehensive overview of the security posture of everything that goes inside the energy sector in Israel. When we're talking about the energy sector in Israel, we're talking about power production facilities. So for those of you that don't know, Israel is undergoing a privatization process of power production. Right now, about 60 to 70% of the power being produced in Israel is being produced by the governmental company, the Israel Electric Company, whereas the other 30% are being produced by the private sector, meaning private initiators that we need to deal with. And those are really the companies, the facilities that we are paying the closest attention to. So the second objective is really to provide a safety net for them. So the idea is that those private facilities are working under the regulation of the Ministry of Energy, and basically, as a government entity, we're not allowed to tell them, hey, you need to deploy this security control from a specific vendor, or this firewall, or this data diode. We're just telling them, okay, this is our security policy, this is what we expect you to do. Go make some contracts with the companies that are your favorite, and deploy your own firewall, your own VPN gateway, your own data diode, whatever security control you can think about. The nice thing, the really innovative thing, I think in a world scale, because we're getting visits from all over the world in our Cybersecurity Center, the big thing is that we were able to build some trust with those private facilities that I've just mentioned, and actually deploy our own sensors, talking in the Splunk language. We're actually installing Splunk forwarders inside their OT network. So IT is out of scope for us because of all privacy and other concerns. We're focusing on the OT network. We have our own Splunk forwarders that are sending all the data from the operational technology network through a very unique, highly secured, there is no 100% security, but we're trying to do our best to get all the data from the facilities into our Cybersecurity Center, going one way, unidirectional, into our facility. And this is when we can actually take all this data together with the data that we're getting from the management of the energy production in Israel, the energy management systems, and actually be able to correlate the actual production, the actual functional data with the computing, or let's call it, cyber logs that we're getting from the various systems. And why we're doing it? Well, the simple answer is that if you're talking about operational technology network, you're talking about PLCs. Again, I will go back to actually mentioning the component in the OT networks. Let's take, for example, a PLC, a programmable logic controller. Basically, it is a device, a computing device that has a CPU, a controller that has its own operating system, but has no keyboard, no display. So if this device will be attacked, if a malware will reside actually on this device, someone will be able to manipulate the firmware of this device. That there is no antivirus on this controller. No one will be able to see the prompt or act upon it. So what we're trying to do is actually correlate the actual power production data that we're getting with the actual network logs, the actual logs that we're getting from the various security controls. And actually, you can see a pretty much anonymized picture of our main control room. On the right hand, you see the screen that are displaying the operational and functional data, and on the left hand, you will see Splunk and the incident management application that we're using. So, going back to our primary objective, really generate this kind of cybersecurity posture score for the whole energy sector. What they are saying. You cannot protect what you don't know about. So you need to actually, you need to have this inventory list that will say, okay, those are the devices that's supposed to be in those facilities. This is really what I'm looking at. This is the data that I'm getting. Now I can work on it. So this is the actual reference to the two projects that I mentioned before. While actually looking into the ways of solving these problems, lo and behold, we found that the US NIST, using its National Cybersecurity Center of Excellence, the NCCOE, came up with basically the same plan. And here you can see, I think this is the busiest slide that I have in this slide deck. You can see basically that they have the same design. So they have the remote sites where you have all the control systems, all the raw network traffic will be forwarded to data servers, to passive sensors, and to forwarders that will forward all the data to the enterprise location. And also one news flash, as part of the disclosure that they did, that the NIST did about the vendors that they've chosen to actually carry out this project, Splunk was also chosen. So this was also a nice surprise, kind of, you know, I'm trying to build this thing with Splunk, and someone in the US thought about the same thing, you know, great minds think alike, or copying is the ultimate flattery, choose what best fit you. But basically their scope was pretty much the same as we were thinking about. Doing asset discovery, so establishing a full baseline of the physical assets that they have on the network, identify the assets of what operating system, what protocol, what are the MAC address, any other metadata that they can have about the devices, assets visibility, asset disposition. I will not go into all the verbiage there. And of course, the ultimate goal is to have this alerting capability. So this is one interesting project. You can just copy the link if it is readable, or just Google the NCCOE and look for their updates. The second nice discovery that we've found was during the last Splunk conference. So those of you that are not Splunkers, that are not doing Splunk, Splunk has its own kind of big conference from all the Splunkers across the world. So think about, you know, Checkpoint CPX, I think, and Microsoft Ignite. So the same thing is .conf for Splunk. And last year, we've actually, we found a presentation by Paul Johnson from a company named Discovered Intelligence that was actually doing, again, the same thing in IT, okay, in IT environment, not in OT, but the idea, and if you can just remember the outline of the diagram that you see on the screens, it is pretty much the same of what we came up with. So if you actually want to try out this project that Paul Johnson created, you can just head over, Google SEC 1624, go to Splunk base, download the application. You know, Splunkers know that with Splunk you can just install your own free version on your laptop, get the code free of charge, and you know, start playing with it, see what it is really all about and how it is doing the inventory management. So, to bring you something new for those that are not familiar with operation technology. All of us here know IT. All of us know exactly the problems that we have with IT environment, internet connectivity, cloud services, BYOD, bring your own devices, mobile devices. You know, those are all technology advancements, but from an IT administrator or IT information security specialist, all of those are really big headaches. You know, I think this is something that we can all really understand here. So when you're looking at, let's say, a power production facility, you will see the same IT environment, and this is really all about the 2.5 upper layers that you see over there. So they have their own web servers, they have their own email servers, they have their domain controllers, all the usual IT services. But then when you get down to the actual physical activity of the facility, and again, it can be a power production facility, or it can be a facility that is producing ice cream cups. It doesn't matter. We're talking about some process, some production process. So when you go down to what we're calling ICS, Industrial Control System, or OT, Operation Technology Network, you will see those three layers. So starting from the bottom up, on the lowest layer, you will see the actual sensor and the actual equipment, so all the robots, the motors, the faucets, the valves, and of course the sensors that goes together with it in order to make sure that the physical process is working according to the plan. So all of this is really in the lowest level. Going up, you will find the PLCs, which is really the very basic elementary computing unit when you're talking about OT networks. So again, a computing device, think about a computing device that has its own logic, and the whole thing is just about repeating this logic, getting the feeds from the sensor, if we're talking about a boiler, getting the temperature for the boiler, and then turning the firner up if we want to heat up the boiler. This can be as simple as that. And of course, next to it, which is really a separate headache for OT engineers, is the SIS, the Safety Instrumented System, but this is really a topic for another presentation. Climbing up, still within the OT network, you see computing devices that might be more familiar to you. And here we're talking about HMIs, basically human-machine interface displays that are showing what is the current status of the actual production process. Now, if you go to facilities that are, let's say, 20 or 30 years old, you will find a very constrained unit that has maybe even a CRT screen with some physical knobs and buttons. But the more modern systems obviously are PC-based. And there on those PC-based systems, you can find vulnerabilities ranging from the CPU firmware level vulnerabilities, okay, like Spectre and other vulnerabilities in this level. And of course, everything that goes with any standard operating system. And later on, we'll talk more about it. Next to it, you might find the engineering workstation, which is really the station where the production engineer is actually configuring the production logic. And in some cases, if not all of them, you will also find other devices, some that are more familiar to you, like separate Active Directory, DHCP, and DNS services that are just dedicated to the OT network. The important thing is really the separation between the industrial control system network and the usual IT network. So again, because we're talking about a standard IT network that might be, in most cases, exposed to the internet, you don't want to have any internet or any outbound or inbound connectivity to your OT network. So there is a very distinct and clear separation layer between the ICS and the OT network. Okay. There are many differences. I've just noted some of the difference before between IT and OT, but just as a recap, a summary, a list that, again, is not comprehensive. Don't get me on that. There are more differences that I didn't list here. But basically, when you're thinking about IT network, certainly these days, you're talking about a network which is really secured by design. You will not find a network that is not implementing a network segmentation, firewalling, web application firewalls, all the latest and greatest security controls. When you go to the OT side of the house, and it might be a production facility that just update all the network equipment, most of the time you will not find security at all. Support and patches, this is again pretty much straightforward when you're talking about IT network. You have a vulnerability, you will put it through the patch life cycles. In 1 week, 2 weeks, 3 weeks, you will apply the patch. Forget about it when you're talking about OT. In OT, the two things that you really care about are safety, the physical safety of all the people that are running the production facility, and reliability. You want the production process to go on as planned. Those are the two important factors, and don't disturb them with any security patches or anything alike. Refresh life cycles. In IT, you might find 3 to 5 years life cycles. With OT, you might find facilities that are running the same way 10, 15, 20, and even 30 years. When you're talking about whitelisting, I've mentioned it before. Pretty hard to do in IT environment with all the BYOD mobile devices and things like that. In OT, and this is an important thing when we're looking into doing inventory management, it is supposed to be pretty simple because, again, everything should be fixed, maximum reliability, so you should expect a pretty much fixed environment. So, we talked about risk. This is a formula that should be familiar to all of you, okay? The very basic formula that everyone that goes through the CISSP certification or GSEC or try to read about risk management, we know that risk is a function of threat, vulnerability, and the asset value. Taking this formula and applying it to the OT environment, basically, and of course the process that we are talking about now, inventory management, with threat, I want to know what are the devices that I have on my network because I want to know if certain threat is actually applicable to my environment. Vulnerability, I want to know a certain device, if it is running a firmware, a version, an OS version that is vulnerable. With asset value, again, it might be different from the IT side of the house because if you go to a bank, they will tell you that they most care about the confidentiality of the data and the integrity of the data. Availability, okay, so if there will be some, few hours downtime for their employees or external customer, everything is okay, but make sure that the integrity and the confidentiality of the data will be maintained. Here, when we're talking about operational technology, we're talking about safety and reliability, and those are the primary assets that we care about. So, what do we want to know? We want to know the systems, all the devices that we have on the network, but, and this is the big but, even more important than the device that we were able to extract from the data that we're getting is what we are not seeing. Okay, and this is something that I'm calling, the dark side of the plant. And I will get back to it. Okay, so I've mentioned before that we're getting a live stream of all the data from the different facilities. Just to name a few of the sources that we are actively using today in order to extract the data that we can use to build our inventory management. We're using authentication events, all the events from different hosts or from host to domain controller or servers, network data. It can be a variety of firewall or switches. We're getting all the data, all the network traffic, anti-malware application control, and the latest and greatest addition is information from ICS, IDS. And just for you to remember, when you will see the architecture that we are using right now in our center, the information that we want to get, that we want to extract from all these logs, basically is the host. Okay, it can be the IP of the system or the host name, and we want to record when was the last time that we've actually observed this specific device. So this is really what we are about to extract from all those logs. Now, this is some great slide that I found from an Israeli consulting company called Confidas. Those of you that know, I guess most of you are familiar with intrusion detection systems should know that there is the same thing also for ICS, for industrial control systems. I'm really happy and proud that some of the more prominent and leading companies in this landscape are really Israeli companies, Israeli startups. But the important thing to see here, and this is why I was saying that this is the latest and greatest addition to our system, is that those systems will be able to give you the visibility down to the lowest level of the production control. So if I'm just about getting the logs from the firewalls, from maybe a host IDS or anti-malware, remember that I'm talking about standard Windows or Linux-based communication. But if I want to know exactly what is the attack surface of the full scope of the facilities that I'm monitoring, I need to go down to the physical level, down to the PLC that is not running any Windows OS, does not have any terminal, any keyboard, is not sending me any logs, but those devices, those ICS intrusion detection systems are actually able to provide me with some visibility into what's happening down there, very close to the sensors, to the motors, to the valves. And this is also one more piece of information, very important, that I'm collecting in addition to all the events that I've mentioned before. So, with Splunk, Those of you that are working with Splunk and didn't make any acquaintance with the SIEM, with the Common Information Model, not to be confused with SIEM, the Security Information and Event Monitoring, you should. Because basically normalizing all the data that you are collecting, in our case, it is really something very pivotal, very important, because we're collecting data right now from tens of facilities running all kinds of devices from different vendors, everything that you can think about. So if I want to build a coherent inventory list of all the devices that I have in my sector across different facilities, I need to normalize my data. And the way to do it with Splunk is using SIEM. So the first two things that we've actually started with, and I think after actually experiencing and developing this method are a good start, are the authentication and network traffic. So go ahead and try it. Enrichment. So in addition to all the events that we're getting, the host, the IP models, there are 3 resources that we are now using in order to enrich the data that can be also very helpful to you. So first is the manual asset inventory mapping. So someone before me, I think the guy from the NKIC mentioned that the inventory list, basically the papers, the documents within every facility are your ground truth. The same thing applies also to us. And when I mentioned before, looking for the dark side, looking for what should be on the network, and I'm not seeing any telemetry, any traffic from it, this is how I'll be able to derive this data. So basically, comparing the manual asset inventory mapping that was done by the field engineers with the data that I'm getting into my logs. ICS cert, those that are dealing with industrial control systems and are not familiar with ICS cert should head over to this great resource run by the US Department of Homeland Security. I think nowadays it's part of the CISA, should be, where you can see all the vulnerabilities and advisories that are related to ICS OT that are trying really to build a comprehensive list from all over the world across the different vendors, and device monitoring, device history. If you're running some kind of a SOC or security center like ourselves, you have your incident management. All the data that was collected over time about some alerts or some incidents about specific IPs or hosts can be also very helpful. So use this data also. Due to the lack of time, I will skip this slide and go straight to the actual high-level architecture of what we are doing. Okay, so starting from the left side, like I said, we're taking all the logs that we're getting from the facilities, ingesting it into Splunk, normalizing it using SIEM, doing enrichment using what I've just discussed before, and then we're doing 2 things. I'm actually keeping in a KV, in a key value lookup within Splunk, the latest state of each device, meaning every IP, every host, when was the last time that I got an event, a log that relates to this IP. And the second is a summary index that I'm using in order basically to build a history for the specific device. So it's relatively simple, but something that can be extremely beneficial. You have the latest state of the device, and then you have the history. You can derive so many excellent insights about the device this way. And then I can do my searches. So for example, I can see what devices currently communicate, what devices did communicate before and stopped, I mean, just disappeared from the network, what devices should be on the network and didn't send any telemetry, what devices are known to be vulnerable, and obviously what I can say about each device after I did this enrichment using my incident management application and the data that I'm getting from ICS cert. Last slide here is something. There was supposed to be a last slide, or the clicker just stopped from working. This is one slide about the latest incarnation of this project that we are now doing, actually getting into machine learning. So again, the Splunkers among you that didn't find about ML Tk go and do your reading. So Splunk's Ml Tk basically is the Splunk 4 front end for the very great Python scikit-learn. Basically, Splunk created a wrapper around this framework that can allow you to actually implement some machine learning, starting from the basic statistical algorithm, but also some advanced machine learning algorithms on top of all the data that was collected. So I'm exactly out of time. If there are any quick questions. Okay, yes. Okay, so it's a matter of implementation. In our case, because of the kind of mode of work that we are working, subjected to the regulation of basically the Ministry of Energy. Remember, I'm working in a government facility. We don't have the privilege into going into the actual pickup and the actual network streams. Okay, so we just have to do with the events and the logs that we're getting from the security controls that were implemented by the facilities. But we're able to get some of the things that you mentioned with those facilities that chose also to implement those ICS IDS systems. So most, if not all, of those ICS IDS systems are capable into looking into anomalous Modbus traffic. Some have support for more advanced protocols. They raise flags, they generate alerts, generate incidents. I do get those alerts, and I'm using it. I'm using it basically to create an incident based on this information. So the short answer that in our case, we're not doing it. Actually, I've engaged Splunk about this matter. There is a Splunk app called Splunk Stream that is basically doing the same job as Wireshark. I think that I'm not Splunk's official representative. I didn't get any promise that they will implement ICS OT protocols, but they do think about it. Okay, thank you very much.